Hey guys, my name is Iman, and in this tutorial I'm going to explain how to work with a Matlab function called FFBD. It stands for Fast Filter Bank Design. I developed this function to design all types of filter banks, including uniform, oversampled uniform, and non-uniform filter bank. If you want to download this function, please check out the link that I provided below and make sure that you follow all the steps. In order to save time, I already downloaded and unzipped the package. So let's start the tutorial. If you want to learn how to work with this function, just type help FFBD again, Fast Filter Bank Design. As you can see, there is a comprehensive explanation about the function, different inputs, and different outputs. This function is designed based on our paper, which was published in an IEEE conference. So if you are interested to understand the idea behind this function, please read this document, Design of Filter Banks Using a Fast Optimization Approach. Just as a simple explanation, our cost function consists of perfect reconstruction conditions and some constraint on a stopband area. You know, the thing is, in the cost function, we ignored passband repo. We have no constraint on the repo in the passband, and because of that relaxation, we end up with two quadratic functions, one with respect to synthesis filter and one with respect to analysis filter. So by doing that relaxation, we end up with quadratic functions, and we can solve the optimization problem very fast. So this is an iterative approach. First we fix analysis filter and we solve this one with respect to synthesis filter, and then we fix synthesis filter and we solve this one with respect to analysis filter, and we go back and forth. As I said, it's an iterative approach, and we go back and forth between these two quadratic functions until we converge. So basically that's the idea behind this function. Now let's go back to the Matlab function. I'm going to show you three examples. The first one is a uniform Matlab function. It's uniform because the sampling rates are 2, 2. They are the same. That's why it's called uniform. So clear all. So after convergence, as you can see, the distortion and aliasing are very small. These are final analysis filter and final synthesis filter. Again, as you can see, there are some ripples. But, you know, the thing is, actually I'm going to explain it here. The thing is, if this is a ripple, let's say, oh, this is very bad. If this is a ripple from analysis filter, if we have the synthesis filter like this, yes, we have ripple from analysis filter and we have ripple from the synthesis filter, but they can cancel out each other and we end up with one, which is ripple free. So basically that's the idea behind our approach. Now let's go back to second example. Clear all. So this is oversampled uniform filter bank. The reason that's called uniform because all the sampling rates are the same, 2, 2, 2. And you know, we have 3 subbands and the sampling rate is 2. That's why it's called oversampled. So here you can see analysis filter. Here you can see synthesis filters because this is an oversampled uniform filter bank. That's why the amplitude response for synthesis filters is a bit weird. But if you look at the aliasing and distortion after the convergence, they are very small, and we can say perfect reconstruction conditions are almost satisfied. The last example that I want to show you is a non-uniform filter bank. So it's called non-uniform because the sampling rates are not the same, 2, 4, 4. So that's why it's called non-uniform. And we need to wait until the algorithm converge to a feasible solution. Done. So these are analysis filter, these are synthesis filter. Again, we have some ripple here and we have some ripple here, but they can cancel out each other. And if you look at distortion and aliasing, they are very close to 0. And we can say perfect reconstruction conditions are almost satisfied. I think that's it. Thanks for using my function. And if you have any question, please send me an email. Thanks.